In order to carry our insulation resistance test, we need to come back to our machine and change the scale. We're currently on the ohm scale. We're going to stay in ohms, but this time it's going to be in the megohm scale. Often on the channel I still call it megohms, and I always get picked up on it. That tends to be a bit of a slang, doesn't it, for megohm. So I'm going to move it to the megohm scale. And now there's 3 voltages to choose from. For our system, we're going to test it at 500 volts DC. And the on-site guide says that we should achieve a minimum insulation resistance of 1 megohm. However, further investigation at 2 megohm. But if you look in the guidance notes 3, it says for a brand new installation, it shouldn't be less than 20 megohm. Okay, so we've got a brand new installation. I expect the insulation resistance reading to be very, very high. I've done a separate video explaining about insulation resistance and length of conductors, and again I'll leave a link for that video if you haven't already seen it. So for this test, it's 500 volts DC. We're in the megohm scale, often called megohms, and we're going to be expecting a reading very, very high, possibly an infinity reading, or one greater than the machine can read, as we measure its insulation resistance. Just to prove these leads haven't been damaged during the first test, I'm going to short them together on this scale. So I'm going to remove the tips and I'm going to put the crocodile clips on. I don't want to get my hands on the end of here. If I was going to touch both of these ends here, I would obviously pass 500 volts through myself. Remember, that's 500 volts DC. So I'm going to link the two together. I'm going to press and hold my test button now. It doesn't automatically do this test. And as they're joined together, I've got 0, 0, 0, in other words, a dead short, meaning the leads are in good position. If these leads were snapped, and again, I've done a little video on them, and they tend to snap around here, what you end up doing is obviously getting equivalent of it being broken. If I press and hold the tester again, you get a reading greater than the machine can read. So if we're going to short them together to prove that they're not broken, we expect to get 0 or a dead short for that reading. So our leads are good and we're ready to test with these. I'm going to change between tips and probes, but let's look at the consumer unit first. Now, we haven't got the tails in here. We know the installation is completely dead. This is an early test that we're carrying out. If it was a board that was energized when you arrived, there's tons of safe isolation procedures before you carry out this test. But let's think about the things that we must make sure are in place before carrying out this test. We said that the switches, and there's only one in circuit, needs to be left on. The lighting point is back and covers are on, but the lamp itself has been removed. If we had the lamp in here, it would be connected across the 2 pins, and that would be switching line and neutral and would cause you an issue with your reading. So all loads need to be removed because loads are naturally connected across line and neutral. All switches are on, all covers are on. So if we look in here, these are also effectively switches. So we don't want these switches in the on position either, because these components here, so this one here being an RCCB, contains electronic components, and we do not want to pass 500 volts DC through those because they could be damaged. So we're going to make sure everything is in the off position, and we're going to test from the outgoing side here with these off, because if we left it on, the 500 volts would pass up and through the circuit as well as down and across the bottom of the RCCB. So we leave everything in here in the off position. Now, I've left one little conductor here, which you can see doesn't go anywhere, for a reason. This is to remind you that when carrying out the insulation resistance test, the earthing conductor, which comes in with the tails, must be connected and connected to the source earth, as well as any bonding. So in a TNCS earthing arrangement, this green and yellow conductor would go off and be connected the cutout where the neutral is. And in a TNS system, this goes to the sheath of the cable. If there was an earthing terminal, an MET, this green and yellow earthing conductor would go there, and the bonding must be in place. So if the circuit has bonding to gas, water, oil, etc., all of the bonding conductors must be connected in this earth bar as well. I know at college that's probably not going to be the case, and you're not going to have these in place because obviously it's not connected to the electrical system. But the sooner you hear the fact that when you carry out your insulation resistance test, the earthing conductor and bonding conductors must be in place and connected when carrying out the test, it helps you to move through your levels on your understanding and knowledge. So I've left the earthing conductor in as if it's connected to the source earth for this test. There is no order in which to carry these out, not even a Gary order, so it doesn't matter which way around we do it. So I'm going to change one of these over for a probe. So I'm going to connect between my earth bar, and it doesn't matter where I go on the earth bar because they're all connected together in a brass bar. So anywhere on the earth bar, at the top of my breaker, and test between these here and here. I want to press my test button. I need to press and hold it. I've got a reading greater than machine can read, greater than 999. The symbol on the end is the greater than. I like to put plus in my test paperwork, so I would put plus 999 megohms, okay, often called megaohms. So that's the first one. We're going to now test between the earth bar and the neutral bar. So if I move my probe across to here, press and hold firmly, and then press the test button once again. And we can see we've got a reading greater than 999 megohms. And then finally, we need to test between the line and the neutral. Again, it doesn't matter which way around your test leads go. So I'm going to test on the line connection and where the neutral is. Again, it wouldn't matter where I go. So I know that's the terminal I'm testing, and people get obsessed with putting it on top of there. This is a solid bar, so it wouldn't matter where I probed onto. So I'm in those positions there. I'm going to press and hold. And again, I've got a reading greater than 999 megohms, often called megaohms. Okay, so greater than the scale of the machine can read. So a lot greater than the minimum accepted in a BS 7671's on-site guide of 1 megohm. Certainly greater than the 20 megaohms suggesting guidance notes 3. And we would expect this reading to be massively high. So what we're trying to prove is that the insulation around our conductors has not degraded between them. So we don't expect these to have broken down over time, or perhaps friction caused them when pulling in to rub against each other, and the insulation between it is starting to break down. These are brand new cables. We expect it to be a fantastically high reading, and we got a reading higher than the machine could read, and we would record those readings for me as plus 999. But sometimes people use that greater than symbol. But again, I like to put plus in there. So that's the insulation resistance test carried out.